This is Ermias Brown from Wargit University. I'm an assistant professor on computer science, and I'm served as research and community service coordinator at Wargit University, and I'm also an assistant professor on software engineering. I'm presenting here for machine learning lecture. This is machine learning summer school, which will be conducted as a virtual for Tübingen 2020 at Germany, and the title will be Software Complexity Prediction, a combined machine learning approach as my presentation. Actually, I have only 10 minutes. I will go so fast. If you want detailed information, you can contact with me directly. It is an outline. Then, if you come to an introduction, so software companies are increasing complex systems, but you have measures through software testing and customer feedbacks. But we have seen three basic problems. The first one will be customer does not provide an actionable feedbacks. It occurs too late to make correction. Software testing is costly and time consuming, meaning there is 40 up to 50% will be consuming as a cost and time. So there is a solution in order to solve those problems that will be through machine learning algorithms will be helps in order to develop a model. That model will be by providing a data and develop a model. Finally, we are going to test by using that models. In order to develop those models, we have different approaches. It may be supervised or unsupervised or in enforcement, but in this research, we are going to combine both supervised, actually mainly unsupervised algorithm. We are going to combine by using both algorithm, and we have used NASA MLP dataset. As a problem, many project managers are emphasize when to stop testing and which part of the code will be testing. So as software and complexity of software, as the size and complexity of software increases, it will be prone to errors or prone to some problems. So various research have been interested on building defects. It may be some research may be developed by using matrix label, some developed may be classified by using some with matrix. But in this research, we are going to use matrix and also with classifiers. And still, the researchers did not consider different programming language, combined two methods, particularly on both simple method and different programming languages is not considered as far as my knowledge. It is objective as general and specific objective. So we have designed and developed software predicting model is my general objective, and we have go through this specific objective in order to achieve the general objectives. And here will be a methodology, literature review, data source from NASA MDP, designing and developing this. We have machine learning tools, Java, line of code metrics, Rust, and MySQL Server was applied for this research. Here is the evaluation metrics, confusion metrics, precision, and recall. Here is related workers. It will be classified in three categories. That's classification approach, as you have shown on the top of the table. And also there is also a clustering approach, and there is also an ensemble approach that was done by some researchers. And here will be what software metrics and the proposed approach. As you have know, in engineering discipline have so measurement. So software engineering is not unexceptional. So it's its own measurements, such as it will have quantitative based measurements. So here is a diagrammatical approach. What software metrics mean? So there is software metrics, and it will be classified into two categories: product metrics and process metrics. But we have give an emphasis on product metrics. It may be size metrics and cyclomatics metrics. Here is the detailed information about what is software metrics mean and what will be cyclomatics metrics mean. So here will be the detailed finally it's here. And another thing is in machine learning will be a feature extraction. So measurement of software product is a prerequisite and to understand a control establishment. Then you have measured or extracting by using here it's a software metrics or plus software metrics and analysis, and also line of code metrics was applied with some programming language. Mainly you have high achievement was performed on Java, so we have extracting features from Java programming languages. It is an algorithm that we have used. You have classified into categories, single and combined. So in the single, we have decision tree, artificial neural network, and support automation. If you come to a combined classifier, we have used both for combination of all these three single classifiers. And if you come to a design of a defects, here is a design look like. So as you have shown here, we have two parts. The first part will be this one, and the second one will be a prototype system. So as you have shown, we have NASA MDP and we have pre-processing steps, noise removal, handling of missing values, and other things. And we have also here splitting of a data with tenfold cross-validation, and here you have a data or training data with provide for an algorithm that you have selected, and you have a testing data for those develop model. Finally, you have generate rules with accuracy. Finally, we have once we have developed or generate rules, we are gonna to provide for load model for the developed prototype systems. Then we have a new softwares. Finally, we have extracting the features from source code by using pressed and line of code metrics. Finally, we have input selected feature to the user interface. Meaning you have used MySQL servers in order to load automatically instead of feeding each and every attributes. Finally, you have user interface, and it will be classified. It is prone to error or may not be prone to errors. Then we have the chapter 4, data understanding. It was conducted in three categories: choosing and collecting the data. How can you choose and how can you collect data set will be one of the basic things that you have considered. What was the description of selected attributes or data sets? Finally, how attribute will be selection. Some of data sets may have 38 and above that. Some of them may have 28 data attributes. So how can we select those attributes that will be relevant to our study? Then finally, with domain experts, we are selecting 22 attributes. Here is a way how we can choose. Well, there is around 13 defect data sets. Among those, we have only given for this one, and this was based on different programming language. With code metrics was our choosing criteria among 13. It is some dataset descriptions and attribute selection and discussion. We have by using various metrics in order to choose those things. And finally, we have holistic metrics, base measure, driver measure, line of code was used. And if you come to experiment, it was conducted into categories. The first one will be with single methods, and as you have shown on the top, there is J48, MLP, SMO, and as you have shown here, we have also some data sets, and here will be the result by using correctly classified precision record for both algorithms. And finally, the high achievement was conducted on or promising result will be JC3, and it was developed by Java programming language. And the same thing if you come to combine those single methods, and high performance also conducted or promised result was achieved on KC series. Performance measure, the fortes, MLIT, all are mentioned here, but the basic thing in order to you see here is when the size of data increase, the number of leaves, size, time taken build is increased, but here there is some misconceptions or misunderstanding, that is record precision accuracy of the model will decrease. So what was the problem? This one will also come up later. And in order to, so here is some accuracy diagrammatical representation look like. As you have shown, KC3 is high achievements. And if you have shown here, effect of a dataset when increasing a dataset, decreasing machine learning method because of increasing complexity of the model. So the model will be increased highly, or number of trees will be high. That was one of the reason might be increase the number of floors will be generated, and also decrease the model accuracy and precision will be if you are increasing a data set may be happen. It will be some of the feature extraction by using pressed and line of code metrics look likes, and it will be the prototype or classification systems. And finally, here will be once we are providing, if you are clicking on load data, it automatically feed or text boxes. And if you are clicking a predict button, it automatically shows it is it may be fault or non-fault. And here will be the comparison with other related workers. Conclusion and future workers, it will be objective to study plain combined machine learning algorithm for predicting software metrics, and based on the performance, the best algorithm where KC3, that is by using J48 with SMO classifier, SMO and J48, but high accuracy was performed by here. In the future work, we have extend our directions or recommendation to the following: extend the model to more software courses such as Eclipse, Git, open source softwares, and R data. And in effect of attribute, if it may be attribute reduction, we have choosing only 22 attribute, but we have various attribute reduction algorithms. Once you have applied that one, what will be the outcome is also another research areas. And in the future, also recommend other software metrics in addition to product metrics, like you may consider resource metrics or product or process metrics is also some of recommended work for the future. And the main recommendation as a why the fault occur for a given software product is also a basic future research area, and able to provide a detailed explanation of why that was happened for those errors, and what will be specific solution for those errors also. Another research area was what I am recommending. Finally, you cannot measure what you cannot measure. You cannot manage what you cannot measure is a proverb which was said by DiMarco. Thank you for watching and listening this summer school presentation. Actually, I am so fast, but I am only provided 10 minutes in order to present these things. That's why I am being fast. Thank you so much.